Good morning, good morning, good morning. Sorry for the small delay which we had because there was a small power cut and had to get everything back on track. So here we are, and this is your 7 higher order thinking questions for your JEE Advanced 2025. And I want all of you to challenge your thinking abilities. I want you to get out of the mains mindset and start thinking literally out of the box for the JEE Advanced. You have to slowly start pushing. Okay, you might not reach 100% in the month of February or March, but if you are at, let's say, 20%, getting to 30% is important, getting to 35% is important. Slowly, within the next 1 or 2 months, you have to reach your highest thinking of your abilities. All right, so let's begin with the class, and I hope I'm audible and visible to all of you. Hello, Avinash, Ashwin, Rukmini, welcome, Ellen. Welcome everyone. Welcome. Yes, this is your Captain Shreyas, your physics master teacher, and I have been teaching for JEE NEET for a very long time and sending all the kids to their desired dream colleges. And this year, obviously, I want to make sure that your dream is fulfilled, and that's the reason why I'm coming over here on YouTube just for you. So make sure you are quickly smashing that like button and subscribing to the #1 JEE English channel in the country. Thank you so much, my dear students. Yep. HOTS full form. H for hot. No. H for higher. O for order. Okay. Thinking. Yes. Higher order thinking. Yes. I hope this is clear. All right. So let's do the first question coming up on your screen. Uh, Galvatron, you're not getting the PDF. Let's see if I can find somewhere, and maybe I'll share the link on my Telegram. Okay, or maybe if you can DM me on my Insta or on my Telegram, I will try to figure out if I can find that. Else, at least SL Aurora, if I can give you that, I will give you. Okay. Yes, Vijay, I know, I know. Because the moment you said Physics Galaxy PDF, I understood you are my student from yesterday's mentorship. Yeah, great. Arms of U-shaped tube are vertical. The arm on the right side is closed and the other arm is closed by a light movable piston. There is a mercury in the tube and initially the level of mercury in the arms is the same. Okay, so let's understand. This is a U-tube. There is mercury filled here. There is some air gap here. This part is fixed. It can't go up. This can't go down. So whatever air, atmospheric air has been trapped here, it can't escape out. If the mercury goes up, this gas will be compressed. If this mercury goes down, this particular gas will expand. Okay. But this part has a movable piston. It can go up and down. At the same time, this level of mercury can go down or up depending on what is happening here. And this manometric fluid can go up, down like this. In fact, in the next state, you can see exactly that happening. And that's what they have described. Above the mercury, there is an air column. You can see there is an air column of height h. And the initial pressure is the same as the atmospheric pressure in both the arms. So there is atmospheric air which has been trapped in this part and this part above the mercury. Till this point, are you able to visualize? I hope this is absolutely clear. Yeah. Good morning, everyone. Hi, Suni. Hi, Akhil. Good morning, good morning, good morning, everyone. Yes, join in, join in. Now, okay, yes, perfect. Now, let's say X is the displacement of the mercury level in one of the column and there is some compression. P2 is the pressure in the right column of the air and P0 is the atmospheric pressure. Then there are some multiple uh, options over here. More than one can be correct. It's not single correct. Remember, this is JEE Advanced. So more than one options is possibly correct. The next slide, I think, will have the answers. So we are not going to see it. We're just going to see how to solve this particular question. Till this point, absolutely clear, everyone? Till this point, absolutely clear what is happening in the problem. Now it is our turn to start solving the particular question. Okay, let's start. Now, first of all, realize one thing. Whatever gas is there over here, whatever gas is there over here and over here, it is basically the same thing. And as you can see in the options, the first option is talking about the pressure here. The second option is talking about the pressure here. The third option is talking if this pressure and this pressure is equal. The last option is talking about the relationship between the pressure here and the pressure there. Okay, so let's see what we can do. Now, this particular gas which is being trapped here, and this gas, like I said, is the same thing. So it's a isothermal process. If it's a isothermal process, then what you can do? Yep. Why? Because temperature is not changing. Nowhere has it been mentioned that something is changing drastically. No, the temperature can be assumed as constant. So if temperature is assumed as constant, isothermal, so P1 V1 should be P2 V2. So right now here the pressure is P naught, then the pressure becomes P1. So can I not say P naught into volume? Volume will be area of cross section into the length of the column. So area of cross section into the length of the column is H. Okay, so that is the volume, is equal to final pressure, which is basically P1 into the volume. Now area of cross section into the volume. What will be the volume? Just think about it. What will be the volume? It will be area into the length. Now the length, how much will it be? This is what do you think this much part of that particular column is going to be? Yep, come on my dear students, come on my dear students, is it going to be h by 2 plus x, or is it going to be something different? Is it going to be h by 2 plus x, or is it going to be something different? You can see it directly over here, my dear students. If this is h by 2, it's already mentioned in the question, you have pushed it down by h by 2. So if this is h by 2 and this is particularly x, then obviously this much part is also going to be h by 2. Just see, if this is h, this is h by 2, this is also h by 2, h by 2, h by 2. If this is h by 2, this is x, how much is this? This is obviously h by 2 plus x. So that is also going to come over here. So this was actually the final volume in the second part. As you can see, area cancels. Therefore, P naught multiplied by h is nothing but P1 multiplied by h by 2 plus x. So option A is definitely correct. Option number A is definitely correct. Can you see that, everyone? Yep. Cool. So this particular volume needed the length calculation. This length will be this plus this. This much will be this, which is h, minus h by 2. So the remaining is h by 2. H by 2 plus x is h by 2 plus x. That's what the length is. Okay. Now for the second gas, this particular gas. Again, the gas trapped over here is atmospheric gas, so P naught. And now I think it is getting compressed over here. This is pressure P2. So again, using temperature constant, I can say initial pressure into volume. Volume is again area into H, will be final pressure P2 into the volume. Now what will be the volume? Area into this length, area into that length. Now how much is this length going to be? Well, this complete height was h. From that you take away x. From h you take away x. So won't it be h minus x? Just check this out. Area gets cancelled. So P naught into h will be P2 into nothing but h minus x. So P2 into h minus x, h P naught. So that is option B, of course. So this is also going to be a correct answer. This is also going to be a correct option. Everybody till this point? Okay. Now the third point, is P1 equal to P2? Is this P1 equal to P2? Obviously, these expressions are not matching each other. Neither can we say that directly it is equal. So definitely C seems to be very doubtful. In fact, you can see something over here. This is the manometric fluid, right? The mercury manometer's manometric fluid. This point and this point inside the fluid should have same pressure. Reason being, this point and this point are at the same depth or same height, so the pressure should be equal. This point and this point, the pressure should be same. In a hydrostatic fluid, same logic I can apply. In the same fluid, the pressure should be equal. So what is the pressure here? It is exposed to this air, so therefore the pressure over there is P1. What is the pressure here? Well, it is this pressure which it is exposed to plus this extra height. So P1 will be equal to P2 plus density of the fluid, which is, let's say, rho, into, let's say, G, and this particular height. How much will this be? Well, this is X, this is also X. So this particular thing over here, which you can see, is obviously going to be 2x. So into 2x. Now we can rearrange this. So P1 minus P2 is basically rho G 2x. Rho G 2x, I think rho is missing. I think that row is misprinted over here. So I'm just adding it. I believe that row was there because they have mentioned where dash is, where actually row is the density of the mercury. So definitely this option also seems to be correct. Naturally, C option is incorrect. Just check this out. A, B, and D. Yes, we got it right. Loved this question. Shall we go ahead to the next question? By the way, if you are wondering where I'm picking these questions from, I am also picking some of the questions from this particular book, which is the JEE Advanced Rank Accelerator book, which has unique questions for JEE Advanced, which are not PYQs, which are not there in any other books. There are of 2 levels with detailed solution. Plus, you get a lot of free content along with this when you scan the QR codes. So that's where I'm picking it from. All right. So let's go to the next question, my dear students. Okay, what is this? Image distance, object distance by convex lens with some radius of curvature is shown. With same radius of curvature is shown. The refractive index of the lens number 1 is 5 by 2. Find the refractive index of lens number 2. Okay, think about it, my dear students. Think about it, my dear students. The graph is given. Do we know something from this particular graph? Is this graph going to tell us something? Does this graph of image distance versus object distance tell you something? Maybe it should tell us something. Let's see. If you observe it carefully, this particular dotted line is shown at 45 degrees. Okay, maybe for a reason. If it is at 45, whatever is there on this side and this side will be exactly symmetric. So if this is 20 centimeter, so this naturally should also be 20 centimeters. And not just that, even if this is 30 centimeters, by logic, this should be also 30 centimeters. This is object distance magnitude. This is the distance of the image magnitude. Oh, maybe I should use this. Maybe I should use this to find out what is the focal length in every case. And by the way, there is a standard thing that the image distance magnitude always equals the object distance magnitude for a lens when the object when the object is at double the focal length. You know this. This is standard ray diagram. If there is an object here, then the image will be formed exactly over here. If this is 2f, this will be also 2f. This you get it using ray diagrams. Oh, I know this. So if the object distance in the first case, if it is 20 centimeter, so therefore the double the focal length, double the focal length in the first case is nothing but 20 centimeters. So therefore, F1 is just 10 centimeters by this particular logic. Also, for the second lens, 30 centimeters is the object distance or the image distance. So 2 times focal length is 30 centimeters. So therefore, I can say F2 is nothing but 15 centimeters. F2 is nothing but 15 centimeters. Till this point, everybody clear? Now, one might argue, sir, what if it was not 45 degree? Let's say it was 60 degree, 37 degree, 30 degree, or some other angle. Then, okay, instead of 20, I will get maybe say 15 or 40 or something like that. So I will get object distance, I will get image distance. And which formula will I use? Can you put it up in the chat box? If let's say by chance, this was not 45, this was something else, what will happen? Instead of 20, I will get some other number. Let's say chumma, I'm saying some angle, some value. Let's say it was 30 centimeter or let's say it was 40 centimeter, example. So then I'll use the formula 1 by V minus 1 by U is 1 by F1. There is no other way. You cannot use this property if it was not 45 degrees. Is that making sense? So again, you will start with 1 by V is let's say 20 and 1 by u, let's say it is minus 40, is 1 by f1. From this, you will get the value of f1. Same logic you will apply for the second curve, and you will get f2 also. But the good part about this problem is that we have 45 degrees, so we were able to use this particular property for now. Is this absolutely clear, everyone? Okay. Now, what is the next step? The next step is to find the refractive index, and now we know that 1 by the focal length is refractive index minus 1 by r1 minus 1 by r2, and now this much part is going to be the same. So focal length is inversely proportional to mu minus 1. So therefore, I can say f1 my f2 will be mu1 minus 1, and this will be mu2 minus 1 because it is now inversely related to mu minus 1. So just have to substitute everything and you will get the answer. What is f1? f1 is basically 10. What is f2? That is basically 15. What is mu2? I think that is what we have to find. So I'll put mu2 as it is. What is mu1? Mu1 is basically 5 by 2. Okay. So what is this going to be? 10 by 15. That is going to be 2 divided by 3. So just do the cross multiplication. 2 into 5 by 2 minus 1 is equal to 3 times mu2 minus 3. Now what will this become? 2 will cancel. All right, 2 will cancel. So this will just become 5, and minus 2 is equal to 3 times of mu2 minus 3. All right, so 5 minus 2 is basically 3, and this minus 3 will become plus 3 is equal to 3 times of mu2 right over here. Just check this out. Yes. So 3 plus 3, that's going to be 6, is equal to 3 times of mu2. So mu2 is just going to be 2 units. So mu2 is going to be basically just 2 units. Just check this out. All right. So this was 10, this was 15, this was mu2 minus mu1, this was yes, mu2 minus mu1, and this was 5 by 2 because that is the refractive index of that lens minus 1. So you just cross multiply. So 2 into this. So 2 cancels, becomes 5 minus 2. Yes, 5 minus 2 is basically 3. Then 3 into mu2 over here minus 3. So minus 3 goes onto the other side as plus 3. 3 mu2 remains. 3 plus 3 is 6. 6 by 3 is basically 2. So the refractive index will be 2 units. Everyone, Aruna, I will be making separate videos for class 12th. Don't worry. Okay, we'll be making separate videos for class 12th. And class 12th physics board, which guide do you prefer, sir? For exemplar is better. Exemplar, but has some good level questions also, Aruna. Okay. I mean, some of the questions are actually, mains level also. So yeah, you should be little bit confident about your basic syllabus before using as exemplar. That's what I would suggest. Okay, my dear students, moving on to the next amazing question. Everybody ready for the next question? Everyone? Yes, Ashwini, Akhil. Okay, great, my dear warriors. Okay, so let's see what the next question is all about. In this particular arrangement, I can see one disc, I can see one pulley, I can see one spool, meaning two radius, two threads attached at different distances, and a block which can slide on a smooth surface, but this guy is on the rough surface. So two different surfaces for two different objects. Okay. To ensure pure rolling of the spool, the mass of the block is m, the surface below the block is smooth, find the initial acceleration of the block system, etc. Pulley P is frictionless, the threads are massless, the mass of the spool is m. I think this guy is also m, this guy is also m, and the disc is also m. Mass m, mass m, mass m, massless. Okay, I think I had kept a separate diagram, but let's see. And the question is find the acceleration of the block. Okay, so let's just look at the diagram alone and see what we can do. So obviously lot of free body diagram is there. I can see rolling concept is also there. I can also see Newton's laws is also there. And I need to be extremely careful with the diagram because if I make a mistake in the FBD, then everything will go wrong. So let's try to understand the forces first and then we'll proceed. Okay. So first of all, for the disk, I know its own weight will act like this. So I will just say mg downwards. Then this guy will have its own weight like this, which will be mg downwards. There will be also a normal force on it. Let's say I call it N2. There will be also a normal force over here. Let's say I call it N1. There will also be its own weight, which is mg. Let's say there will be tension T1 over here. The same tension will act on the spool, and that will be called T2. There will be some kind of friction because this surface is rough. I will call it F. Then there is a tension over here. Okay, sorry, why did I say T2? My bad. This was also T1. My bad. This was T1 and this will be friction. This will have some tension. Let's say it will be T2. That same tension will be carry forwarded here, and that will be also T2. I think these are the only forces which are acting, but that is not enough. Yeah. All right. BTT karo means what do you mean, Rohan? Okay. All right. So now concentrate, guys. Guys, this is J advanced session. Please don't ask random questions now. Please focus on the session or ask questions on this particular problem. Okay, that will be better. Now that is not enough. We have to also show the accelerations. If you miss the accelerations, everything will go wrong. Okay, so let's start assuming things. Let's say this guy has an acceleration A, which we have to find out. It will move this way. The center of mass of this particular disk will have, let's say, acceleration a1, and the center of mass of this particular disk has an acceleration, let's say, a2. This disk will also have some angular acceleration. Let's say I call it alpha 1, and this disk will also have some angular acceleration. Let's say I call it alpha 2. Okay, that's all. Nothing else is there. So let's start writing down our basic equations and see what do we exactly get. And I feel I need a relationship between these variables also. So, these acceleration variables. So I'll make a separate diagram A. Then this is basically your A1. This is basically your A2. This is basically your, excuse me. This is basically your alpha 2. This is basically your alpha 1. Okay, I will need the relationship also. That's why I kept a separate diagram. Let's start writing the equation. Starting for the block. Now, if you write the equation for the block, what will it be? There is only one force in the horizontal direction, and that mass will accelerate because of that. So this is your first equation that you get. Then let's write down the equation for the spool. So for the spool, what your equation would look like? Well, there is T2 here in the direction of favoring the acceleration, T1 against it, and the friction is also against it. No other force in the horizontal direction. So Newton's law wise, shouldn't it be T2 minus T1 minus F is equal to the mass into acceleration? Yes, the mass into acceleration. So it will be nothing but m into A1. Is this fine? Everybody with me? Yes. Awesome. Awesome. Yeah, we'll be doing pure lectures for boards also. Yes, definitely. Now, the mass of the disk and the radius of the mass of the spool is m, and the moment of inertia of the spool is also given as half mr square. I think that by 2 is missing. Okay, half mr square. Okay, we'll use that later on. Next, for the spool, we can also write the torque equation. Yeah, think about it. It is rotating, so there is a torque by tension to T1 and also F, and it is having an angular acceleration. So the torque equation, apart from the linear equation, will look like this. Due to T2, which is acting at a distance of R, the torque will be R into T2. Then, due to T1, the torque is at R by 2. The force is at R by 2. So, plus R by 2 into T1. The friction is at a distance of R. So, plus R into F1. This is the net torque. This is basically your net torque. Now, that net torque will be I alpha. Moment of inertia is half mr square. So, 1 by 2 mr square into angular acceleration, which is basically alpha 1. which is basically alpha 1. If you want, you can cancel r. Therefore, it will become T2 plus T1 by 2 plus F is equal to M R alpha 1 divided by 2. So this is not F1, this is just F. This is just F. R into F. Yes. So this is my third equation, which I got from looking at the block and the spool alone. Making equations for this is more important than solving it. That is very important, guys. So let's go to the disk now. Let's go to the disk and see what equations can we get. On the disk, looking at the translatory motion, mg is down in the direction favoring the acceleration, t2 is upwards. So therefore, I can say mg minus t2 is equal to mass times that guy's acceleration. So that is equation labeled 4. Okay, t2 is against, mg is favoring it. I've used Newton's second law, F is ma. I will also use the torque equation because it is rotating. So obviously I need to make as many equations as I can to solve so many variables. So let's see, what do we do? Okay, let's see what we can do. Well, first of all, is mg going to give any torque? Obviously not. Why? Because it is from the center. The mg force is from the center, it will not give torque. Just like over here, this normal and mg was not participating in the torque. It was only T2, T1 and F which were trying to rotate that spool. Okay, and T2 torque, T1 torque, F torque, all were in the same direction, anti-clockwise. Same thing here, the T2 torque is there, mg torque will be absent. So the torque of T2 will be at a distance of r. So r times of T2, I think it's a disk. So again, it will be mr square by 2 into the angular acceleration, which is basically alpha 2. R will get cancelled. So I will get T2 is equal to mr alpha 2 divided by 2, which is equation labeled 5. Yep, is that right? mr square, rr got cancelled, mr by 2 alpha 2. Great. But is it still solvable? I feel no. Even though we have 5 equations, I feel it is still not solvable. And why do you think it is not solvable? Why do you think it is not solvable, guys? There are too many variables. There are too many variables for this particular problem to be solved. We need more equations. Yes, we need more equations. And that will come from constrained motion. How? Observe carefully. Look at this block, this point over here and this point over here. This particular point over here on the block is having some acceleration. So let's draw it properly so that you understand it, because or else there are good chances that you will make some silly mistake over here. Now, I am concentrating on this point, which is connected to this point via a thread. Because they are connected via a thread, whatever acceleration this point has, let's say it is A, even this point should have the same acceleration. Do you guys agree with it? Both the points should have the same acceleration because the string connecting them, the length is going to be constant. So both points have same motion, same kind of motion, 100%. Else the string will become slack, which is connecting both these points. Now observe. How do I find the acceleration of this guy? Well, this point over here is moving forward because of the spool. The spool is taking it front, but at the same time, because of the rotation, it is moving behind. When you study rolling, it is taught in two different ways. Try to recollect. A rolling motion can be thought as if the sphere, the cylinder is toppling about the point of contact. It is the instantaneous axis of pure rotation until the next point comes, and that becomes the axis of pure rotation. Or you can consider it to be a combination of translatory and rotatory motion. A rolling can be combined as is a combined motion of rotating and translating motion. So the translation part is of the spool. So just visualize it as if the center of mass is taking it forward by an acceleration of a1 translation. So this is basically your translation. But at the same time, you are being pushed behind. You are being pushed behind because of the tangential velocity, tangential acceleration. And that tangential acceleration, think about it, how much will it be? It will be alpha, which is alpha 1 into the radius, which in this case is basically r by 2. So that is the tangential acceleration, which is pushing it behind. The linear motion is pushing it in the front. So this should be your resultant motion. So A should be technically A1 minus AT. So therefore, it will be A1 minus alpha 1R divided by 2. So that is basically A. That is basically A. It is A1 minus alpha R by 2. Is this absolutely understood? Is this absolutely understood, my dear warriors? Okay. So this is another equation. Let's say I call it the sixth equation. Let's say I call it the sixth equation. Apart from that, this alpha and A are anyways related to each other because it is rolling. So for rolling motion of that particular spool, I can immediately say A1 is equal to alpha into R. That was pretty much direct. There is nothing to think about it. So I can label it as equation number 7. This entire spool center acceleration is angular acceleration into R because it is rolling. Just like V is omega R is only valid for pure rolling. A is alpha R is only valid for rolling motion, not for slipping motion. Okay, perfect. Now comes the last part. I think we have not written any equation for this guy, so we'll write that down. So this will be the eighth equation which we'll write down, and then our job will be done. Okay, how to do that? First of all, to find this guy's acceleration, let me redraw it over here again. Okay, to find this guy's acceleration, what I want you to see is concentrate on this particular point here. This point is actually moving because this thread is moving. So this thread is moving. So this point is also moving. And with respect to that point, this point is moving down. So if you notice clearly, with respect to the center, this cross goes up. With respect to the center, this cross point which is there, it goes up because of the rotational motion, because of that rotation, because of that spin which is happening with a tangential acceleration given by alpha 2 into r. This point with respect to this rotates. In fact, all the points have tangential acceleration like this. We all know that. Yeah. So they all spin with alpha 2 into r. So if this has this much acceleration with respect to this point, do the exact, yes, Uno reverse. They say Uno reverse. So same thing I will do over here. With respect to this point, how much acceleration will this point have? How much acceleration will the center have? Just quickly think and tell me. Obviously, it will be alpha 2 into r. I've just applied Uno reverse, guys. With respect to this guy is moving up, accelerating with alpha 2 r. So with respect to this guy will be coming down with nothing but alpha 2 into r, into alpha 2 into r. Is that right, everyone? Oh, so it is with respect to this point. So this is now with respect to this particular point. This center is coming down with alpha 2r. But this point itself will be coming down. How much will it be coming down? How much ever this point is moving. How much ever this goes down, how much ever this goes down, same amount this will go this side. How much will that be? Think logically. The center goes with A1. Remember, the topmost point has double the velocity. So obviously it will have double the acceleration. So needless to say now that this point has an acceleration of 2 times of A1. It has an acceleration of 2 times of A1. V to V, 0. Remember, in circular motion, that is the scenario. I will draw it for all of you. So if this is a rolling body, right? If this is a rolling body, remember this will have some velocity. This will have the highest velocity. and that will be 2v. Anything else in between will have lower velocities, and as you go at the point of contact, it has zero velocity. So from 0 to v to 2v, so 0 to a to 2a. So that is how the accelerations or velocities are. So many concepts. Oh, so if that is going with 2a1, obviously this is also coming down with 2a1. So with respect to this point, this guy was coming down with alpha 2r. So therefore the center of mass has the net acceleration. Therefore a2 therefore a2 will have not only alpha 2r with respect to this point, but this guy's downward motion, which is going to be 2 times of a1. So this is basically your eighth equation. This is basically your eighth equation. So we have 8 equations now. All of these 8 equations need to be solved, and that's when you get your final answer as 4g by 37. Okay, that solution part, you do it, but I have written down the most important equations for you. This is going to be one of the crazy problems which you need to solve to understand rotation, understand rolling, understand the concept of center of mass, Newton's laws, free body diagram, and how this pulleys, etc. work with constrained motion. Okay. Is that clear, everybody? Did you love this question? Yes or no? Give me a thumbs up in the chat box right away, right now. Okay. Let's go to the next one coming up on your screen. Okay. Loved it, Avinash. All right, Mohammed. Chandan, I will answer all your doubts maybe later on, because these are advanced classes. So we need full focus, my dear. Okay. On these concepts. Okay. Great. Now, the next question. The linear mass density of a non-uniform wire under constant tension decreases gradually so that the incident wave is transmitted without reflection, absorption, nothing. And the wire is uniform from minus infinity to 0. The wave equation is also given. Y and X are meters, stages in seconds, SI units. Basically, from 0 to 20 meters, the density decreases slowly. And from there onwards, till infinity, the mass density is constant. Okay, I think it's better that we visualize what is exactly happening over here, else we are bound to make some mistakes. So imagine there is a thick wire. Imagine there is a thick wire, something like this. Okay, and then that same wire is going to become thin over here, and there is a transition which is happening from here. There is a transition which is happening from here to here. Yes, there is a transition which is happening. And let's label those points also. This particular point is x equals to 0. This particular point is x equals to 20. And remember, this now will continue till positive infinity. And this would be coming from negative infinity. Now, what is happening over here is there is a wave which is moving towards this side with some speed v1. And that wave equation has been given 0.003 cos. That wave equation which is given is 0.003 cos of, what is there, 25x minus 50t. 25x minus 50t. That is what is given. And the mass density also has changed. So if the mass density over here was mu, it has become 1/4 over here. So this has become mu by 4 over here. So some things will change, some things will not change, and that is what the question is. The wave speed, what will it be? What is the wave equation? In fact, in the wave equation, amplitude and some other values also have changed. So we need to basically find what will be the wave equation over there. And it is clearly mentioned that ignore any losses. Basically, there is no reflection at all. So there is nothing which is going back. Everything is purely transmitted. Everything is purely transmitted. Okay. So let's try to understand for this particular guy, what will be the new velocity be? Some things will be same, some things will be different, mind it. What will be same for this wave as it passes on to a slowly, gradually reducing thinner string? The string was thick, slowly it has become thinner, and the mass density, linear mass density, has become 1/4. What do you think will remain the same? Quickly let me know in the chat box. Is it the speed which will remain the same? Is it the wavelength which will remain the same? Is it the frequency which will remain the same? I think it will be the frequency, isn't it? Frequency will not change, but wavelength and wave speed both will change. Why will speed change? Because mu has changed. The mass density has changed. So in a thinner string, the speed will be much higher. Frequency is dependent on the source. So the same rate will continue even forward. It's just that because the speed is different, you will see that the wavelength will be different. When the speed was less, the wavelength is less, but as the speed increases, you will see that the wavelength will also be more. Okay, only frequency is same. So is there any relationship for the wave speed? I think so. We know a particular formula, I believe, and that formula is V is root of tension by mu. Guess what? Even the tension will remain the same. You know why? Because it's the same string. So whatever tension you have applied here, the same tension you have applied over here. So the tension in the entire string, it's the same string. You pull it, that tension builds up in every bit and piece of that string. So it is the same whether you're here thick side or the thin side. Oh, so that is also critical. So essentially, velocity is inversely proportional to the root of mu. Therefore, I can just say to find out V2, I want to find V2. So V2 by V1 will be root of, for V2, what is the mass per unit length? It is mu by 4. For V1, the mass per unit length is mu. So mu cancels, it will become root of 4. V2 is over here. Do I know V1? I think so. How? Look at the wave equation. See, it is not mentioned directly here, but we can find it from here. How? This value is basically k, this value is basically omega, and we know wave speed is nothing but omega by k. Omega by k. And this is omega 1, let's say this is k1. So omega is 50, k is basically 25. So basically it is 2 meters per second. So the wave 1 is moving with 2 meters per second. So just put, instead of v1 over here, just put 2 over here. So from this, we are going to get v2 as root 4 is 2 into 2. Therefore, v2 is 4 meters per second. Perfecto. So I found this value of v2, and that is 4 meters per second. Great. What do I do now? What do I do next? Observe carefully. Once I have got this value of the wave speed as 4 meters per second, I know one thing, the omega will still remain the same. Omega 1 will be equal to omega 2, right? The frequency will not change. So omega 2 will be equal to omega 1, which will be still 50 radian per second. So the wavelength definitely will change, k will definitely change. So v2 will be omega 2 by that new k. K is the angular wave number which decides the wavelength. So in my equation which I'm going to eventually build for the next wave over here, that will have some new amplitude. It will still have cos. It will still have cos. The angular wave number will be different. It will still have minus, it will not become plus. The angular frequency over here will be omega 2, and then it will be t. I know omega 2 already. I know k2. I just don't know a2, what it is. Okay. But before going ahead, I just remembered that out of the first two options, I can mark at least the wave velocity after a large value of x. Large value of x means what? X is 100, 1000, 1 lakh, 10 lakh. So Over here, that is the speed. So the speed will gradually increase and it will eventually become 4 meters per second. So definitely this 4 meters per second is there. So B is correct. A is obviously incorrect. Is this clear till this point? Everyone? At least one option we got. You should be very, very happy. Yes, sir. At least one option we got, sir. So happy I am, sir. Okay. But that is not our end of the storyline. We need to go more. And what do we do next? Observe. We have to find the amplitude. Now, finding amplitude is the real challenge. Let's try to do it now. Okay, I don't need this. I don't need this. Okay, V1 also I know already. Okay, it is 2 meters per second. Okay, V1 is basically 2 meters per second. Now, to find the amplitude, think what can we use? I think we have missed some information somewhere. And you have to relook at the problem. I have underlined one word, reflection. No reflection. No reflection. That means all the energy is just going on to the string on the other side. This is very, very critical, guys. So this is very, very critical. Basically, energy is transferred. Energy is transferred without any kind of loss. All the energy goes. Yes, energy is conserved. Very good, Siva. So the power of wave 1 is the power of, and the power formula, try to remember, half mu v a square omega square. Here it will be omega 1 a1 v1 mu 1. This will be half mu 2 v2 a2 square omega 2 square. Perfect. Half cancels. Half is just going to cancel. Okay. So let's say what is mu 1. Mu 1 is basically mu. And please remember, I have just cancelled half and half. It is not needed at all. Okay. Mu is mu. V1 is basically how much? It is 2. Amplitude 1 is this guy, which is 0.003. And this whole thing is squared. Omega 1, I think I need it. Oh, I don't need that. Guess what? Guess what? Omega 1 is equal to omega 2. So just cancel that also. Why to unnecessarily waste? Okay. So this is done. We are sorted. Nothing else is there. Okay. Amplitude square, omega square, mu, v. Okay. And this is going to be equal to mu 2. The second mass per unit length is mu by 4. V2 is nothing but 4. Amplitude 2 is what I will need. Okay. Mu cancel. 4 cancel. Therefore, what will I get? A2 square as 4 cancel, mu also cancel. Check this out. Over here, I will be just left with 2 multiplied by 0.003 whole square. So from this, what will be A2, my dear students? 0.003 into root of 2, which is 0.003 multiplied by 1.41 approximately. So how much will this be? How much will this be, guys? Come on, sit and calculate and quickly tell me how much is the second amplitude coming? Is it somehow coming out to be 0.0042 or 0.0021? 0021 or 0042? Come on, tell me quickly. Yes, 0.0042 approximately 0.0042. Wow, very good. Yep, because it is 14, right? 14 and 3. Yeah, you can do that, 42. So 0.042, if I'm not wrong. Yes, 0042. Yep, perfect. It's there somewhere over here. Yes, it is there. 0.0042, guys. Yep, definitely we are done and dusted. So A2 we have found out, everything else is known. So therefore Y2 will be 0.0042, and then we have cos. K2 is basically 12.5, and then this is X, and omega 2 is omega 1, which is 50, and then this is T. I think this equation is definitely there over here. So that is option number D. So we are done. This is wrong because of this guy. This is not correct. This inside part was correct. This was also not correct. Okay, so B and D. Very nice question. Loved it. Did you all love this particular question? Yeah, it's on waves and how they have used energy conservation, how they have used frequency is same, how they have used tension is same. Minute things are there in the problem. Okay, and I have mentioned every bit of it. Every bit of it. Okay, so let's go to the next particular question coming up on your screen. Get ready for it, my dear students. Beautiful question. There are two conducting shells. Okay, which question number is this? I'm not remembering how many questions we have done till now. Okay, this fluids one, of this one focal length 2, this pulley one 3, this is the fourth. Yeah, we are now on to our fifth question. Okay, we are now on to our fifth question, guys. So let's see the fifth question. Okay, consider two shells, minus q and plus 2q, radius r and 2r. Find the charge distribution. Now they are connected to each other. Find the new charge distribution and also the energy loss in this process. Okay, so I have drawn the two shells for you. Let us duplicate it because there will be multiple configurations. Consider two shells having charges minus q and plus 2q. So just imagine this particular shell has minus q, and this has basically plus 2q as a total charge. What happens is the shell's inner surfaces and outer surfaces will start developing charges. Whenever you have concentric shells questions, always start from the inner shell and then go to outer if there are multiple shells. Now, what you will do is, for solving these questions, always check what charge is present inside. Is there any charge present inside the shell? Is there like a plus q charge? No, right? If there was a plus q charge, then the inner shell's inner surface will have negative charge. But right now, there is no charge over here. So 100% I know that this particular surface will have zero charge. And why is it? Because inside there is no charge present. So this is the inner surface. This is the inner surface of the inner shell. Yeah, inside there is no charge. Now, whether this minus q will stay, where will this minus q stay now? Obviously, it has to stay on the outer surface, because if inner surface does not have it, it has to stay on the outer surface. So by logic, I can immediately say this should be minus q. And how did I get it? By charge conservation. By charge conservation. So by charge conservation, I can immediately tell this minus q has to come outside. Great. Now, who is facing this negative q charge? The inner surface of this outer shell. Whenever you have two surfaces facing each other, whether it be plates or whether it be shells, they always have the same charge. This comes via Gauss's law. Okay, there is a detailed explanation for that. But remember this trick: whenever you have two surfaces, conducting surfaces facing each other, isolated, then you will definitely see the surface charges are definitely going to be opposite. So this is going to be plus q. And the reason for that is opposite faces will always have opposite charges. Oh, so there is plus q over here. Now, the outer shell should have a combined charge of plus 2q, out of which plus q is in the inner surface. Naturally, the plus q should be on the outer surface, the remaining one. This again is via the charge conservation. Charge conservation. That's all. So this is again via charge conservation. So that completes the charge distribution. That completes the charge distribution of those two shells. Is that absolutely clear? Okay. Now let's go to the second part. If they are connected, now this is the interesting thing. The moment you connect it, the moment these shells are connected, what happens? That wire makes the potentials equal, makes the potentials of the shells the same, and all the charge which is there here wanted to move out, wanted to repel. Unfortunately, it could not go beyond this because this is a non-conducting air gap. So if given a chance via this conducting wire, all this negative charge immediately immediately goes on immediately goes on to the outer surface or the outer shell. So what will happen? is the charges, the charges, the charges on the inner shell, on the inner shell, due to repulsion, due to repulsion, move out, move out to the outer shell, outer shell. So what is the new net charge, new net charge on the outer shell? On the outer shell, think about it. Earlier it had a charge of positive 2q, but the negative q charge entered onto it, so the new charge will be basically q, and therefore no charge will be left. This is very important. No charge is left on the inner shell, on the inner shell, nothing is left. So you will see basically zero charge over here, zero charge over here. Inner surface is facing this guy, so this will also have zero. So only the outermost surface will have a charge of plus q. All the charge what was there has just flown out. The moment you connect it with other shells, all the charge will just flow out and it will stay on the outer surface. If there was one more concentric shell and if there was a wire connecting here, all these charges will flow out and it will sit on that shell. The more outer you go, the more likely they want to go as away as possible, so they will try to reduce their energies by moving out and out because of the repulsive forces. Is that clear, everyone, till this point? Understood? Very cool, very cool. Now if this is the new distribution, this was, so this is also done. Now they are connected, so find out the new charge distribution. So this is also done. Old charge distribution also done. Visualize what has changed. Visualize what has changed. You will immediately get the answer. You will immediately get the answer for the energy conservation, how to exactly solve it. I'll tell you what. Look at it like this. Look at it like this. Okay, forget these diagrams. Just imagine this shell and this shell versus this shell and this shell. Okay, just imagine this. Earlier, nothing was there inside. This was negatively charged, negative Q. Okay, then this was obviously positively charged, an equal amount. This was positively charged like this. This was positively charged like this. And the outermost surface had some positive charge. Again, plus Q. Right? That is what we had figured out earlier. That is what the charge distribution was before. So 0 minus Q plus Q and plus Q. So that is what I have done. 0 minus Q plus Q plus Q. Later on, what has happened? 0, 0, 0 plus Q. Oh, that means only the outermost charges have remained as it is. It was like intact. Nothing happened to it. So in this process, from going to here, what do you think went away? Do you see those yellow charges which are facing each other, positive and negative? They went away. Okay. So what, sir? What next now? What is your point? What is the point that you are trying to convey? Don't you feel for a second that actually speaking, this is like a capacitor spherical type? How many of you are able to visualize? This is basically a spherical capacitor which has stored electrical energy between the two shells. Yes, sir, there is electrical energy between the two shells. And there is another capacitor which is like the outermost charge which is there. It is storing energy from there to infinity. It is storing the energy from there to basically infinity. That is not affected at all. That energy is still there in the outermost region. From that outermost shell to infinity, that energy is still intact. I have not touched it at all. It is only that inner energy which got destroyed. So think of it as if there was a capacitor, not any ordinary capacitor, a spherical capacitor. It is like a spherical capacitor with electrical energy stored, electric energy which has been stored between 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 the shells. And now that energy is not there, so definitely all that energy has been lost in in equalizing the potentials or in the flow of charges to equalize the potentials. So all that energy went away. So whatever energy is lost is the energy stored inside the capacitor. So I will say that the energy which has been lost is nothing but the energy stored inside the capacitor, and that is given by half charge square divided by C. Half the charge square divided by the capacitance. Okay, let's see what is the charge. What is the charge over here, guys? I think we know it already. Minus Q and plus Q. That means the charge is basically Q. You always take one of the plates charge. So it is basically Q. So put Q square over here. Divided by the capacitance. Divided by the capacitance. What is the capacitance of this particular spherical type of capacitor? So that capacitance, remember there is a formula 4 pi epsilon naught 1 by R1 minus 1 by R2. So this is basically, let's say R, this is 2R, it is already mentioned. R and 2R are the radius. So this will be 4 pi epsilon naught. 1 minus half is half, so 1 by 2R. So this will become 8 pi epsilon naught R. 8 pi epsilon naught R, that is the spherical capacitance. So 8 pi epsilon naught R. So this will become nothing but the charge square. 8 2s are 16. So 16 pi epsilon naught R. So that is the energy or the heat which has been produced. Got it? I will not use half CV square. Reason being, I do not know the voltage. That will be a more complex calculation. Charge calculation was simpler. Rather, it is already found in the first two parts. So that is the reason why I stuck to half charge square by capacitance formula. Did you all love this question? The way it moves. Okay. It started like with very simple thing, right? And then you are connecting it, okay, equalizing the potentials, fine, all the charges will repel, it will try to flow out, nothing is there inside. Then it became like next level. Suddenly it escalated too quickly and it became a capacitor problem. The energy stored between the shells got destroyed in the process of equalizing the potentials, and that's why the energy in the capacitor is also the energy which is lost. So this is spherical capacitance formula. We used it and we got it. Cool? Clear? Everybody? I hope you are smashing that like button. I know, see, number of students watching these videos will be very less because obviously JEE Advanced, number one, number two, boards are there. Number three, many of you might not be even aware of the channel, plus, okay, advanced, should I prepare, not prepare? So it's your job to tell students and tell your friends that, listen, boss, prepare for JEE Advanced, don't waste your time. In fact, if there are some seniors and juniors, you should guide, each other that, it's very difficult to crack JEE Advanced in the last 1 month. Okay, especially after mains, you have very little time now. So please make sure that you are preparing for JEE Advanced from now itself. If you are above 90 percentile, there should be some percentage of preparation. Yeah, fine. If you are close to 91, 92, maybe your percentage will be less. But if you are close to 95, it should be more. If it is 98 and above, it should be even higher. And if you are expecting above 99.5, 99, you should be watching all these videos. There is no doubt about it. Correct? Okay. Moving on to the next question. Let's see. Equiconvex lens placed 40 centimeters in front of a concave mirror. Focal length this much as shown in the figure. Object 2 centimeter high is placed 20 centimeters to the left of the lens. The options are given, is it? Yeah, the options are given. The location of the intermediate image, nature of the image in all the cases, overall magnification is how much. Okay, so basically it is a step-by-step procedural problem from what I can see. So the object is given at a distance of 40 centimeters uh, sorry, is placed, no, lens is placed at 40 centimeters, object is at 20 centimeters. Okay, now one thing is there, see guys, this particular focal length, right, is already known to me. I think that is given to be as 10 centimeters. And if this particular object, is at 20 centimeter, the object is basically at 2f. If this is f, this is 2f. Where will the image be formed? Where will the image be formed? Obviously, if it is at 20, it will be also formed at 20, that is at 2f again. So maybe somewhere over here, I don't know where it is going to be. The focal length of the mirror, I think it is 7.5. I'm just chumma writing over here. Chumma writing over here. Maybe this is not accurate to the dimensions. So this is where that image will be. And this image will naturally be at 20 centimeters. So the image is again formed at 2f, double the focal length. Is this very clear? Direct it is till this point. But this is just the first image because of the lens. This is the image at 2f due to the lens. Due to the lens. What will that image become? That image will now become the object for the mirror. But before going ahead, let me write down the magnification in the first case. It will be V by U. Image distance will be plus 20. Object distance is negative 20. So it will be minus 1. Now also the image is going to be real in this case. Real, inverted, and it is right now of the same size. These are all intermediate image. This is intermediate image after the lens, which is now going to be the object for the mirror. Okay, so let me think about it now over here. So forget this exists also. So think there is a object over here. This is at a distance of 20 centimeters. This is now an object. The image now becomes an object. Yes, keep that in mind. This is now the object. So if this is 40, this is 20, how much is this going to be? Obviously, if this is 20, this is 40, this will be also 20 centimeters. This will be also 20 centimeters. So this is the object for the mirror. This is the object for the mirror. Now, what will you do, guys? What will you do now? Obviously, we'll use the mirror formula. And let's use the mirror formula and see what do we get. 1 by V plus 1 by U is equal to 1 by F. Therefore, 1 by V plus 1 by object distance is negative 20 centimeters, correct? The rays from the object are going to go like this. Keep in mind that. So, the rays from the object, they are going to go here like this. Yeah, they are going to go like this. So that side is positive, this side is negative, of course. So, oops. Now what will be the image location? Okay, so this is minus 20. Focal length is 7.5. So 1 by V will be 7.5, that's 15 by 2. So 15 by 2 minus will become plus, it will become 1 by 20, of course. So the LCM is 60, I believe. So 15 4s are 60. So 2 into 4, and this will be 3s are 2 4s are 8. 8 plus 3 is 11. Just check this out. 11 by 60. Everyone, are you getting 11 by 60 or something else? Just check this out. 7.5. Yes. Minus will become plus. Yes. So 4s are 8, 11 by 60, almost 11 by 60, 1 by V. So therefore, image distance, just check this out. Yep. Minus 12, minus 12, minus 12. Just check this out, guys. I think there is some mistake or what? There is a small mistake, guys. I just realized, because I don't think we get some weird answers. So sorry, this was not plus 7.5. This is minus 7.5. This is a concave mirror. The focal length is over here. This is the negative side for it. So there will be a minus over here. Okay. So basically this will be 1 by V is equal to 1 by 20 minus 1 by 7.5. So this will be 1 by 20 minus 15 by 2. So 7.5 is basically 15 by 2. So I can put over here. Yeah, now it makes sense. So this will be basically 60. So this will be basically 3. And this will be nothing but 8. Yes, everybody with me on this? So this will be 5 minus 5. So this will be minus 5 by 12. Sorry, minus 5 by 60. Minus 5 by 60, which is basically minus 1 by 12. So the image distance will be minus 12 centimeters. Just check this out. If you ask me what is the magnification in this case, again, it will be minus V by U. So minus V is minus 12. Object distance was minus 20. Is that right? Minus, minus, minus. 3 times minus. Yes. Minus, minus, minus. 3 times minus. So again, it is going to be inverted, guys. Yeah, again, it is going to be inverted. Yep. Minus. So divided by 2. So it will become 6 by 10. So I can just, yeah, write it as minus 0.6. Okay. So magnification in the second case is minus 0.6. In the first case, it was minus 1. This clearly tells me first time it was inverted. Second time again it was inverted. So I will say it was re-inverted, re-inverted back. And it is on the negative side. So again, it is a real image. And this time also it is again a diminished image. It is again diminished image. This re-inverted also means that again it has now become erect. So this was inverted, again it got re-inverted. So now it is erect. Okay, so where is the image formed? Image is formed at 12 centimeters. So that means I should show the image somewhere maybe over here, let's say. So let's say, for example, Chumba, I'm writing it down over here, or maybe it is here. So this is where your image is. The image is basically going to be formed at a distance of 12 centimeters in front of the mirror. Image due to the mirror. Image due to the mirror. This image is now going to be the object for the lens. Again, you have to do the same thing, guys. This image is now going to be the object for the lens. So if my image is over here, this distance was 12 from the lens. Can you guess how much will this be? Yep. This is 40, this is 12. Obviously, this is 28 centimeters. This is 28 centimeters. So now this becomes the object for the lens. This becomes the object for the lens. Now we know that the rays were coming from the mirror. They are just going to go like this. They are going to get refracted from the lens. They are going to get refracted from the lens. So now this case, this will be the negative side. This will be the positive side. And again, apply your lens formula. 1 by V minus 1 by U is equal to 1 by F. Object distance minus 28. Focal length, it is on this side. Focal point will be on this side. It will be positive. And I think it was given, it is 10 centimeters. So plus 10. From this, try to find the value of V again. Yes. Thank you, Song Tunes. Yeah. Tell me, what is the value of the image distance that you get again? Yes. Try to solve this. Yep. Yeah, it is lengthy, but that's how JEE advanced questions are. So 1 by V is equal to minus minus is plus. It goes on the other side, becomes minus. So 1 by 10 minus 1 by 28. Therefore, 1 by V is equal to, we can take the direct LCM. We can just say 280. So this will become 28 times. This will become 10 times. So this will become basically 18 divided by 280. So therefore, V will just become 280 divided by 18. V is basically 280 divided by 18. Now, once I get that, that is the final location, by the way. Again, that is the final location. Now, finally, the magnification. M3. M3 will be V by U. V is 280 divided by 18. Object distance was negative 28, so minus 28. So this will be some negative value over here. 28 cancels. I hope you can see. So this will be minus 10 by 18. Minus 10 by 18. You can divide it by 2. It will be minus 5 by 9. So again, you can see it is inverted. It is inverted. The image is definitely inverted. It is also diminished again. It is also diminished again. And because of this positive sign, it is definitely a real image. At least few of the answers I think we can mark now. Where did our question go? Few of the answers. The nature of all the images are real. Let's find out, is it true? See, real, diminished real, yes. And this one, real, yes. All the three images are real. Perfect. So this is correct. Location of the intermediate image after reflection from the mirror. From the mirror where the image is formed. Image due to the mirror is at 12 centimeters in front of it. Definitely this is also going to be correct. The overall magnification, okay, that is the last step which is remaining. So for that, what will we do? The nodal magnification is M1 into M2 into M3. So what is M1? M1 I think was -1. Okay, what was M2? I think it was 0.6 negative. Yes, it was minus 0.6. So it was minus 0.6, guys. So minus 0.6. And the last one is minus 5 by 9. Just check out this number. How much does this come out to be? Just check out this number. How much does this come out to be? Yep. Just see if it comes out to be, oh, guys, you don't even have to break your head. 3 times negative is negative only. It has to be this. I don't even have to think. Again, it can't be positive. It has to be inverted. So without calculating only, you can say that, yeah, it will be 0.33 with a negative sign. Okay, so that was the best part. You can just eliminate it. So this should be 0.333, I believe. Okay, great. So that was simple then, right? And you can see why that should also happen. 6 by 9, that's 2 by 3. 2 5s are 10, decimal goes, so 1 by 3, so that's 0.33. Perfect. So that is 0.333. So yes, A, B, C is the correct answer. A, B, and C are the correct answers. What a brilliant question, isn't it? Yeah. So there are high chances of making mistakes in the sign convention, high chances of making mistakes in the distances, image converted into object, and high chances that you misinterpret one of them as real, virtual, and all of that. So that is why it is a good question, plus lengthy, time consuming. So it qualifies for being an advanced question. Now see guys, when you try to do these questions on your own, that's when you also realize how many silly mistakes you make. When you watch me, probably it feels like, okay, doable, yeah, maybe I can pull it off. But when you actually sit, that's when you will see how many places you are getting stuck. And that's when you come to this video and then see a hint and then again reanalyze and then start doing it again. And then you might get stuck again watch this video until you perfect master this particular art. Okay, I hope you guys have smashed the like button. In case you have forgotten, just keeping on reminding you. You guys keep forgetting, that's why. Okay, next question coming up on your screen. There is a small mass of a charge Q and it is attached to the string, negligible mass, length L, top end is fixed. You can see the string is over here, the mass is over here, length is L. The system is now in a vertical plane in a horizontal magnetic field which is inside the plane of the paper. The ball starts with a velocity V0 at the bottom and it completes a circular motion. Okay. All right. The ball moves along the circular path such that the thread will remain tight whole motion, neglect any losses of energy like electromagnetic wave radiation by Maxwell and all of that. So ignore all those Maxwell's radiations. Okay, fair enough. So the question is, where is the question? Okay, there are 2 or 3 questions. If I'm not wrong, this was passage type. What is the magnetic field if the minimum speed which is described by the motion occurs is this much? What is B if the minimum speed required is basically this much? Then what is the magnetic field? That is the question. I think there is one more question, statement based. The direction is reversed Then will conservation be applicable? Will the speeds change, etc.? Those kind of things are there. Okay, so let's start doing this particular question. Let's start. First, let's draw circular motion. Okay. Two positions of that particular ball. This is our center. Okay. Now, first time I will say that the velocity is over here and that is V naught. And when it reaches the top, there will be some other velocity. Let's say I just call it V. Okay. The length of the strings are also given. This is L. And of course, this is also L. If it has to clear the topmost point, then, obviously the tension should be more than 0. So let's draw the free body diagram. One will be its mg force. It has to just clear. That means the tension value should be more than 0. Okay. Then do not forget there is magnetic force also. There is magnetic field everywhere over here. So there is magnetic field everywhere which is present over here. So what do we do in such a case? Let's see. What do we do? Okay, so magnetic field is also there. So QV cross B force will be there. Velocity is there. Magnetic field is inside V cross B. And is it an electron or something? Nothing is given. It's just a charge. So if the magnetic field is inside, then the velocity will be towards the right side. The magnetic force will be upwards. Okay, so the magnetic force in this case is basically upwards, and that will be Q into this velocity into this speed. Okay, centripetal acceleration, do not forget there will be some centripetal acceleration. Let's say I call it A1. So on the top, the equation will look like this: tension plus mg minus qvb is mass into centripetal acceleration. So therefore, tension should be just more than 0 in the critical case. In the critical case, just 0. So if you are talking about that particular critical case, so mg minus qvb is equal to m times v square divided by the length. This is one equation that we get. This is one particular equation. Yes, we get. No, it is not root GL or root phi GL. Remember, root GL, root phi GL is only valid in the absence of other forces, only gravitational force. Here, gravity along with magnetic force is there. So you need to be little bit careful about it. Yeah, you need to be little bit careful about it. Is that okay? Till this point? Awesome, awesome, awesome. Great, guys. Now we will also apply energy conservation and see what exactly happens when you go from here to here. So if you apply conservation of energy principle, if you apply conservation of energy principle, how will it exactly look like? Initially, the only energy that it has is nothing but half m v naught square. There is no gravitational energy. As it goes on the top, magnetic force never does work, so never consider it for work energy relationships. So on the top, it has half m v square plus the gravitational energy, which is nothing but mg into 2l. Magnetic force never ever does work. MMM cancels. So from this, I will just get V naught square on one side is equal to V square plus 2GL. V square plus 2GL. Perfect. So from this, we can put V square's value over here. Can you see? I can put V square's value from there to here. Can you see that? V square's value, we can just put it from there to here. So it's just a matter of putting these equations now. All right. So this is one part of it. Okay. I know after this, I will be able to get this over here. V naught value is also given. But can we also solve the statement based questions simultaneously? If the direction of the field is reversed, then the value of B will be same as calculated in the above question of this paragraph. I feel this statement is wrong. Why do you think? Why do you think this particular statement is wrong? Think about it. Why do you think this particular statement could be wrong? Why do you think this statement could be wrong? Think about it, my dear students. Think. What will happen if I reverse the direction of the magnetic field? If I reverse the direction of the magnetic field, immediately just go back a little bit. This QVB, instead of up, it will be down. Instead of minus, this will be plus. The whole equation will change. The whole equation will change, guys. Can you see that? The entire equation will change. So the direction of the force will change. Hence, that is incorrect. The value of B will be same. This is definitely wrong, as the force of Q into V into B is reversed, is also going to be reversed. That will definitely affect the FBD and the calculations. If B is reversed, the conservation of energy, this has nothing to do with the magnetic field. In fact, I told you over here, conservation of energy is even applicable also, since magnetic force never does work. It's the most laziest fellow ever. So never ever does work. So definitely, this is also wrong. So if B is reversed, the conservation of energy is definitely going to be applicable. So B is definitely correct. Energy will be applicable. B is reversed. Okay. If the magnetic field were not present, then the particle will complete the circle for any value of V naught. No, 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 no. Why any? Why this word any has come? I don't like this word any. No. If magnetic field is not there, then the velocity will be only root 5 GL only. This is the only value, not any value. So C option is incorrect. C option is incorrect. Is that right, everyone? Okay. All of the above are correct, can't be correct because two options are incorrect. Even if one option is incorrect, D option will automatically be incorrect. So B option is correct. And in the previous thing, V naught value was given. So substitute V naught as half root 17 GL. Over here, they have already mentioned V naught to be substituted as, what is it? Half root 17 GL. Half root 17 GL. So substitute this over here. So from this, you are just going to get the value of V square. You're just going to get the value of V square from here. So how much will that V square be? You can calculate. So this will be 17 by 4 GL, because 2 square is 4, minus 2 GL. So this V square you are going to put over here, and then you are going to solve this equation, and then you are going to get the value of B. Okay, just going to get the value of B. So that value of B comes out to be basically 3 mg by 2q root GL. 3 mg by 2q. So it comes out as 3 mg by 2q root GL. Yes, root GL. That is what it comes out to be. Okay, after you solve. So it's a very straightforward procedure from here, nothing great. Main thing is how energy is conserved, not conserved. I think I've also, this is also correct. So B is reversed, then the conservation will still be applicable. It has got nothing to do with it. And there is a homework question which I have put. By what factor is the force on the thread at the point A greater than at point C when the speed is as stated above? So the question is on the force at the top and at the bottom. I will just give you a hint. When you draw the free body diagram over here, the tension will be like this. Mg will be obviously like this. There is only one difference. Velocity is here. V cross B will be downwards. Yes, V cross B will be downwards. So Q V naught into B will be here, and the acceleration of centripetal will be over here. So this will be called as A naught, let's say. So now solve the same thing again. You will get the tension at the bottommost point. So let's say this is T naught. So you can find T1 and then you can solve the problem. Is that okay? So try to solve that particular question. Try to solve that particular question, homework question. So if you have that particular speed is then what is the speed at point A versus at point C? Point A versus point C. I think they have mentioned both those points. This is point A and this is point C. At this particular point also you have to find the tension again by drawing free body diagram. So for point C, so remember for point C, if you draw the free body diagram, the forces will be like this. Tension will be here. Let's say this is tension at point C. Mg will be like this, and centripetal acceleration will be towards here. Velocity is on the top. V cross B will be here. So the force of magnetism will be here. So it will be Q, V, B. You have to find the velocity again by energy conservation from here to here. Okay, there is no other option. You have to find this velocity using energy conservation from here to here. So from this you will get TC also. So after that you will be able to solve it. So I have given you the enough hints for solving that question, which is now placed as the homework question. So please try to solve it. Okay, this was your bonus question for all of you. Answer will be there on the next slide. Okay, and yeah, please let me know the answer in the comment section. I hope you enjoyed these 7 awesome questions and you saw how detailed these questions are, how complex these questions are, and we need to devote that time. And this is exactly what we do in the Ekalavya batch. And these sessions go on continuously. And when the exam approaches, especially after April, or rather from April, or even after your boards in March, the sessions become so intensive that the discussion is of next level. And when you discuss so many questions, you become habituated to thinking in those lines. Right now, that habit formation is the main thing. Then you will slowly start experimenting, and then the confidence builds up eventually. And that is what we do in the Eklavya batch. So if you want to clear JEE Advanced, the only name on your mind should be the JEE Advanced Ekalavya batch. The link is there in the description box. It's a proper dedicated program with a dedicated test series for advanced. Mains is automatically taken care of with the separate mains test series within the batch. Practice test every weekend. All the 3 subjects in pure English. Not just that, you are going to get pure mentorship from the best teachers, a separate set of teachers. They are not regular teachers. They are the finest teachers in the complete JEE industry, and they will be counseling. They will be helping you with the problems, doubts, assignments, special assignments given to you, as well as the JEE Advanced Rank Accelerator book is made, yeah, made for this particular batch, and you are made to solve these questions as well. That is what happens in this particular batch. The batch has just started. You don't miss many classes if you join soon. So please join the batch, and it is for 14,000 rupees for the crash, and the crash pro is for 15,199 rupees. All right, here you get mainly the printed study material, which is the rank accelerator books, which will be delivered to your home at that extra 1,200 rupees. If you don't want that book, only the soft copy is enough, then you can just go for the crash batch. Okay, so the link has been mentioned in the description box. Okay, so check it out. Or if you just want the book only, that option is also there. That link also have put up in the description box. Only the book if you want, that link is also there. Okay, so you can place an order, put your address. It's for 1,665 rupees. So check that out. All the 3 books will be couriered to you. Okay, thank you so much. This was Captain Shreyas signing off. Bye bye. Hasta la vista.